What's up, everybody? In this video, we're going to learn how to create a distance indicator using the RGB LED. When working with the distance sensor, we can't see what your robot sees. We'll use the RGB LED to provide visual feedback that will indicate what your robot is sensing. We'll use a stoplight analogy. Green is good, yellow is danger, and red is trouble. We will combine two previous sketches, the motor driver collision detection and the LED RGB. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our LED-RGB sketch. Hover over the circuit and right-click Tinker this. Open this sketch in a new tab. Next, hover over the motor driver-collision detection circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our sketch in the top left corner and change the name to Motor Driver-Distance Indicator. Select the LED RGB from the components and place it on the breadboard. Connect the cathode to ground with a black wire. Add three 220 ohm resistors from the red, green, and blue pins to another terminal strip on the breadboard. The RGB LED is an analog output. As such, we need pins that are capable of pulse width modulation, PWM. These are indicated with a tilde. Next, connect the red, blue, and green pins through the resistor to the Arduino on pins 9, 10, and 11. Color code the wires to match the colors of the output. Let's jump over to the LED RGB sketch. We are going to copy the code from this sketch and put it into our motor driver distance indicator sketch. Select the three variables we created and copy them. Paste them below the motor variables in the motor driver distance indicator sketch. Confirm the pins are correct in the variable declarations. If you recall, we created a function called RGB that we can use to change the color of the RGB LED. Copy the function from the LED-RGB sketch and paste it below the variables for the RGB LED sensor. Great! Now we can use this function and combine it with our distance sensor. In our setup function, we will need to tell the Arduino that pins 9, 10, and 11 will be output pins. If you recall in a previous video, we created a for loop that will iterate from pins 3 to 8 and write a single pin mode statement within the loop. We can modify the condition in the parameters of our loop to add the 3 pins for the RGB LED. Change the X is less than or equal to 8 to X is less than or equal to 11. If we look at our conditional statements in the loop function, we will call our RGB function to change the color of the LED. This will provide visual feedback as to what the robot can see. Why this is important is that the ultrasonic sensor is not perfect. There are materials it has trouble seeing, and depending on the placement of the sensor, it has a range for where it can detect objects. Tinkercad shows us an approximate visualization of the field of view for the sensor. It is indicated in the blue arc shown when the simulation runs. Let's start off with two colors to indicate what the robot sees. We will change the LED to red if it detects a collision and green if everything is okay. In the conditional statements, we will add two calls to the RGB function. In the first condition, where it detects that it will crash, add RGB open bracket 255, 0, 0. Close bracket, semicolon, to change the LED to red to indicate danger. In the else, add RGB, open bracket, 0, 255, 0, close bracket, semicolon, to make the LED green to indicate everything is safe. Click Start Simulation. Click on the distance sensor and move the ball. The LED should be green if the distance is above 10. When the distance is below 10, the LED will change to red. Great! We now have visual feedback that will show us what your robot can see. This is really important when we are testing, because while you may think your robot sees an obstacle, it might not be able to. The LED will help. Go back to the conditional statements. We will add another condition. This will be a warning that the robot is getting close and will proceed with caution. Right after the end curly brace and before the else, add else if, open bracket, distance is less than or equal to 20, close bracket, open curly brace, close curly brace. Inside the curly braces, add RGB, open bracket, 255, 255, 0, close bracket, semicolon. And forward, open bracket, 175, 175, 25, close bracket, semicolon. So what did we just do? If the robot is approaching danger, we change the LED to yellow. We still tell the robot to move forward, but we reduce the power to the wheels. Essentially, we tell it to slow down and proceed with caution. You can continue to add other conditions or change the distances or behaviors of the robot. What we have created should be used as a guide. At the end of this video, you should have a better understanding of how to add visual feedback to indicate what your robot sees through the distance sensor.